Up to this point, everything we've considered in terms of the trig functions has assumed the angles were between 0 and 90 degrees, and we've dealt inside a triangle. We're going to extend the domain, or the values for which we can take these trig functions for, further by defining some things on what's called the unit circle. The unit circle is just a circle of radius 1. So if you consider the points on this coordinate plane, this point here would be 1, 0. This point would be 0, 1. This point would be -1, 0. And this point would be 0, -1. From our previous sections, we know that we can consider this arc length here, the length for any angle that we've rotated around. The arc length is the radius times whatever that angle is. Well, if the radius is 1, notice that the arc length is simply equal to theta. If we take this theta and we draw a line straight down, this point has a length on this triangle of x, giving us the x coordinate, and a height of y. So for any xy, if we know the theta, we can determine the value of that xy. I'm going to pull out that triangle. This is theta. We have our arc length, which matches that theta. And then we have a y value and an x value. Remember, the radius, because it's the unit circle, is 1. Based on that, then, we can define that the cosine of theta is adjacent over hypotenuse, which leads us to the cosine of theta is x. And the sine of theta is opposite over hypotenuse, which is y. In other words, for any angle theta on the unit circle, since theta is equal to s, we can define the point corresponding to that angle to be the cosine of theta times the sine of theta. So what does that mean? Let's consider a theta that we're familiar with. On this same circle, if I assume that this theta is pi over 3. In other words, the arc length here is pi over 3, but because my radius is 1, theta is also going to be pi over 3. We know the cosine and sine for those, so we can determine that the xy point that corresponds to those is 1/2 square root of 3 over 2. Because again, if we draw it as a triangle, if this is pi over 3, we know our ratios are 1 to square root of 3. But remember, this is the unit circle, so this has a radius of 1. This becomes 1/2, and this becomes square root of 3 over 2. Let's look at a different example. Consider something like an angle now that goes past 90 degrees. If we have this as 3 pi over 4, then we know that this angle has to be pi over 4. On the unit circle, if we pull that out, this is pi over 4, which tells us that this is pi over 4 as a 90-degree angle. On the unit circle, we know this has a length of 1. But if you remember, our ratios are 1, 1, square root of 2 for that triangle. So therefore, we know that our cosine is going to be 1 over the square root of 2. And our sine is also going to be 1 over the square root of 2. But how does that correspond to this xy point? It's in the negative x-axis, so it's -1 over the square root of 2, and the y is positive. So that ordered pair corresponds to a theta of 3 pi over 4. Notice these numbers are going to repeat because I can go around this circle and come back. In other words, all of these numbers, 3 pi over 4 plus any increment of 2 pi, is going to be described by that same point, -1 over the square root of 2, comma 1 over the square root of 2. And this leads us to the summary of what we can say, that the cosine of theta equals x, the sine of theta equals y. Notice that the tangent of theta, remember tangent is opposite over adjacent, is going to be y over x, which also lets us calculate tangent by sine over cosine. And that's a very important relationship that you're going to need. And then notice that secant of theta is 1 over x, except where x is 0. Cosecant is 1 over y, except where y is 0. And cotangent of theta is x over y, again, except where y is equal to 0. So let's practice this a little bit and determine these trig functions. If we wanted to determine the trig functions for theta is negative pi over 2. This is certainly bigger than 90 degrees. But if we go to our unit circle, if we're going to the negative, we can come around 2 pi and then another pi over 2, which puts us right here. And on the unit circle, that corresponds to 0, negative 1. So based on what we said previously, our cosine is our x value. So cosine is 0. Our sine is our y value, which is negative 1. And our tangent here is going to be undefined, since we can't divide by 0. Our secant is undefined, again, because we can't divide by 0. Our cosecant is negative 1, again, the reciprocal. And our cotangent is going to be 0. We can extend these relationships now beyond the unit circle. And to summarize those, what we can do is we can now, for any value or any theta that's in standard position, we can define sine of theta to be the y coordinate divided by the radius of whatever we're dealing with, the cosine of theta to be x over r, and then the tangent of theta is again that y over x. And our reciprocals would still apply for the other trig functions.